All right. Good afternoon, folks. Hopefully, everyone had a good day yesterday. Just want to go ahead and get started with this final problem here. So, this will be it for chapter 12. And then what I'd like to do is start chapter 14. And in order to do chapter 14, what I've done is I've posted for you two fit labs that I would like you to work on after we get done here and work on for the remainder of the period and then turn it in by tomorrow. So I know we don't have school tomorrow, but I'd like you to get it done, get the fit lab done, use the time today, use your time tomorrow, and I would like you to have it submitted by tomorrow night. Um, I would like you to have that done because on Monday, I would like to go ahead and use that fit lab to begin our discussion of gases and the gas laws. Okay, so please make sure you get that fit lab done and make sure you get it submitted by tomorrow night, and then we'll go ahead and get started with chapter 14. Okay? What I'd like to do then is on Monday, I'd like to have a meeting. So I'd like to meet live on Zoom. So I'll post the Zoom meet information for you. And so that ways we can meet. I can update you on what we've done so far and update you on what we will be doing for the end of the semester material and give you an idea of how what we'll have to change to accommodate for what's been going on. So on Monday during our class period, so I'd like us to meet at 12:05. So please make sure you were here. I'd like to meet for just a few minutes, and then I'll let you go so that you can watch the video and complete the lesson on Edpuzzle. But I'd like to meet live just to kind of see how you folks are doing, and then also I'll give you an update on what we'll be doing to finish out this semester. Okay, and so please make sure you show up for Monday. Make sure you get the Fit Lab done for Monday, and again, the Fit Lab will be due tomorrow night. So make sure you have that, and then we'll finish up the semester. Okay. All right, so so I'll quickly try to work through this problem here for you to give you the rest of the period to work on the Fit Lab. So please make sure you go to Classroom and take a look at the post there. I posted the assignment there for you, and also make sure you turn it in and get it done, okay? All right, so we want to finish up with number 32. So this was homework from set D from chapter 12. If you have any questions on the worksheet that is due tonight, that is more practice in stoichiometry, make sure you come by today after school. Of course, I have to end the office hours a little early. I have a meeting that I have to go to, and so the office hours from 1:30 to 2. So come on by and get your questions answered if you have any questions at that point. Okay. All right. So with that said, then let's go ahead and let's take a look at what we have to do here. So this is a problem that I want us to do. It gives us a chance to practice everything we have to do that we've learned in chapter 12 so far. And it's a good problem to finish out this chapter because it reviews everything that we've learned. Okay. All right. So with stoichiometry then, what we were doing is we were comparing quantities. Okay, we're comparing quantities of the reactants and products in a chemical reaction. So stoichiometry is the branch of chemistry. It is the study of quantities as it is applied to chemical equations, chemical reactions. Okay? All right, so to do this problem then, they want us to find the percent yield. Okay, so to find percent yield, then we need to find the theoretical yield, identify the actual yield, and then work through the three types of calculations, the three calculations you have to do in order to get your percent yield. Okay, so let's go ahead and get started then. To start out then, remember for all stoichiometric calculations, the very first thing you have to do is always get the balanced equation. Okay, so this is equation that should describe the reaction between nitrogen and hydrogen to form ammonia. Okay, so this is a chemical reaction that we've been dealing with quite a bit. Okay, and okay, so now we have to make sure we balance it. So there'll be a 1-3-2, a 1-3-2 balance equation. Okay, so that's what we are given. That's the chemical reaction that we will be examining initially. Okay. All right. Next step then is make sure you identify everything that is described, the quantities that are described for you in the problem itself. Okay. So with that said, then we are told in the problem that we start out with 15 grams of nitrogen and also 15 grams of hydrogen. So those two values, those two quantities are given to us in the problem. It's described for us in number 32. It tells us then that we start out with 15 grams of nitrogen, 15 grams of hydrogen. Okay? And then they tell us then that if we form 10.5 grams of, and let me go ahead and write that really quickly, 10.5 grams of ammonia. Okay, what would the percent yield be? So what I've written it for you in red is taken directly from the problem. The problem describes for us each one of those quantities. Okay. All right. So what they're asking us to do then, at this point, then what they're asking us to do is they're asking us to find the percent yield. They want us to find the percent yield, and specifically, they want us to find the percent yield of ammonia because that's the only product in this reaction. Okay. All right. So with that said, then. Remember, there are 3 calculations you have to do. 3 calculations you have to do, and we're going to each do this in turn if we have to. We have to calculate for the limiting reagent if we have to. We also then, from there, we have to find the theoretical yield. Okay. We have to do that calculation. So do the theoretical yield calculation. Okay. And then, so write that down. So we got to find the limiting reagent. We have to find the theoretical yield. And then finally, from all that information, we can go ahead and then find the percent yield. Okay, so those are the 3 calculations that we have to be able to do. Okay. All right, so question then is, do we have to calculate the limiting reagent? Well, first of all, do they tell us which one of these 2 reactants is the excess? They don't. They don't say anything about that. So therefore, they don't mention anything about the limiting reagent, but what they do give us is they give us the starting amounts of both of these. Whenever you see that, if they give you the quantities for both reactants and they don't mention which one is the limiting, they don't mention which one is the excess, you have to do this limiting reagent calculation. Okay, so we have to do it here. Okay, why? Because once we figure out which one of these 2 is the limiting reagent, we would use that one then to find the theoretical yield of the product that we should expect to get. Because remember, the limiting reagent is the reactant that runs out first. And if it runs out first, it will limit the amount of product that we can obtain. Okay, so we have to calculate for the limiting reagent here. And to do that, just pick one of these 2 here. It's an arbitrary pick. It doesn't matter which one you pick. It's what matters is how you interpret the number at the end. I'm just going to arbitrarily pick this here. So in the limiting reagent calculation, this very first one, it is a stoichiometric calculation in which we compare the amounts of the reactants. So what we're doing here then is we're saying that if we start out with 15 grams of nitrogen, which we have here, okay, how much of the hydrogen will we need to use this up? Okay, so we're going to go ahead and calculate for this. Okay, so with that said, then if you notice, this is the setup for these for a stoichiometric conversion. Okay, and so we start out then with 1 mole of nitrogen. Okay, and then this will be 28 grams of nitrogen. Remember, this is a diatomic molecule. All right, mole ratio for these 2 then, it'll be a 1 to 3, so, I'm sorry, 3 to 1. It'll be 3 moles of hydrogen over 1 mole of nitrogen. And then finally, the molar mass of hydrogen, which is going to be 2 grams of hydrogen over 1 mole of hydrogen. Okay. All right, so you plug in those numbers, and you get this value here. You get 3.21. Okay, so what do we do with this number there then? Okay, well, remember, from this point then, we have to compare this value here to the value that's given for hydrogen. So we determined then that this is the calculated value for hydrogen. That's what we calculated for, which means then this is the amount that we need. This is the amount of hydrogen that we need, and this is the amount of nitrogen, hydrogen that we have. So we're going to compare the calculated value versus the given value. Okay, so let's go and do that. So the calculated value for hydrogen is 3.21 grams of hydrogen. The given value of hydrogen is 15 grams of hydrogen. The amount that's given, that's the amount that we have, is a whole lot bigger than the amount that we need. So remember, the calculated value is the amount that is needed. Okay, so this is the amount of hydrogen that's needed to use up this amount of nitrogen. So the given amount, that is what's described for you initially, is a whole lot more than what we need. What does that tell us about the hydrogen? Hydrogen is the excess. So this calculation then tells us the hydrogen is the excess, which means then, just by process of elimination, we only have one other reactant, that nitrogen is our limiting reagent. So in choosing nitrogen here first, and in choosing to do this calculation, we have determined the excess reagent, and then from there we can deduce the limiting reagent. Now, if we had chosen to do the calculation with 15 grams of hydrogen to start out with, we would have seen then that the amount here would be less than the amount here, less than the amount here, and so and the amount here is greater than the amount here, and so therefore nitrogen would be the limiting reagent. Okay? All right, so, but again, we don't have to do that second calculation because here we've already determined that hydrogen is in excess based on this comparison right here. We've determined that hydrogen is the excess, so therefore nitrogen is the limiting reagent. We can take that information now. Now that we know this, okay, we know then that nitrogen will run out first, and so based on that, we're going to use the 15 grams of nitrogen now to determine how much ammonia will form. Okay, so this will be then our theoretical yield. So the amount here is the amount that we expect to get. Okay, that is, if everything runs well, that's the amount of ammonia that we will expect to get if all 15 grams of nitrogen gets used up. And so again, this ends up being another stoichiometric calculation. So we're doing two conversions here, two stoichiometric conversions here in order to find the number that we need to find the percent yield. Okay. All right, so plugging it in then. Let's go ahead and work this out. We have 1 mole of nitrogen, 28 grams of nitrogen. Okay. This time it's nitrogen and ammonia. So we're comparing nitrogen to ammonia, so it's going to be a 2-to-1 mole ratio. So there's 2 moles of ammonia over 1 mole of nitrogen. Okay, and then finally we're going to use the molar mass of ammonia here, which is going to be 17. It's going to be 17 grams of ammonia over 1 mole of ammonia. Okay. All right, so with that said, then you plug in those values and you get this number here. You get 18.2 grams. Okay, so what does this number mean then? This number here is the amount, this number here represents the amount of ammonia that we expect to get. This is the expected value. That's what theoretical means. This is the expected amount of ammonia that we should get. Okay, we're going to compare this to the actual amount. Remember, this here now that's given to us here. This is the actual yield. And remember, you have to be able to identify that. So this is the actual yield. That is, you run the reaction. So someone ran this reaction, and this is the amount of ammonia that they were able to measure out. So the actual amount here is the measured amount. So that's the amount that we were able to measure out. This is the expected value that we calculated for. Okay, so therefore then we use these two values here to get our percent yield, because remember, in the last calculation here, the percent yield is a ratio that compares the actual yield, okay, to the theoretical yield. So that's the ratio there. And since this is a percentage, we take that ratio and we take it out of 100. Okay. All right, so let's go ahead and plug in our values. Actual yield is what we identified there. That's 10.5 grams of ammonia. Okay. Our theoretical yield is what we calculated for, which is 18.2 grams of ammonia. And if you notice, and like I pointed out, we always expect, for the most part then, that the actual yield will always be less than the theoretical yield. We will always obtain less than what we expect to get, because of all those issues that we talked about. I pointed out to you human error, the chemical reactions wrong. We had side reactions to run. So therefore, then the actual amount will always be less than the theoretical amount, which means then the yield will always be less than 100. Okay, and so when you plug this in, then you get a yield that is 57.7%, and that is the answer that they want you to record. Okay. So all of this work here, folks, this is what you have to do to get to the percent yield. Okay, so do you have to do this all the time? No, you don't have to. What you do then is you identify what you were given. So always do that first, because once you've identified that, you may be able to save yourself this first calculation. Okay, especially if they don't give you the amounts of both. If they give you the amounts of both reactants, more often than not, you can count on the fact that you have to do this limiting reagent calculation. However, if they only give you the amount of one, more likely than not, they'll tell you that the other one is in excess. If that's the case, then you can skip this first calculation here. Okay, so read the problem carefully. Make sure you are able to determine then what you're given, because that'll help you quite a bit. Okay. From there, then you can find the theoretical yield, you get the percent yield, and then you calculate it that way. Okay. So this problem here is a very good problem. So make sure you review this. Again, go back and look at this. Use this here to help you do the problems. Compare this to what you did yesterday. Okay, hopefully you had that submitted. And then use this to help you do the homework that's due tonight. Okay, and use that to help you. Okay, so make sure you get this done. Come by and see me today after school. Make sure you come by or come by on Monday and get that extra help and gets done. Okay, so this finishes up our discussion of stoichiometry in chapter 12. I know it was a little bit longer, but this is a skill that for some of you who are moving on in the sciences is a very important skill to do, to know, to be able to do. And so make sure you practice it and come by and get that extra help. Okay. All right, so with that said, then I'm going to finish up here. And I know that this ran a little bit longer, but I wanted to give you a little bit of time to go ahead and get started on your PhET lab. To get started on that, you have today, you have tomorrow. Make sure you submit it by tomorrow night and then have it ready for Monday for the discussion that we'll have on the gas laws and gases on Monday. Okay? All right, then, folks, have a good weekend and make sure you get the work done. And if you have any questions, come by and see me. Okay? Have a good day. I'll see you on Monday. So I'm sorry, one last thing. Make sure we're going to meet live on Monday. So I'll post the Zoom meeting material. Make sure you come by on Monday, and I'll let you know what's going on with the rest of the semester. Okay? All right, very good. Have a good weekend, folks.